Hello student, this video lecture is prepared for heat transfer subject and I will discuss the unit number 6, that is known as the evaporation. So in last lecture I had discussed vapor compression. In that I had discussed mechanical recompression and thermal recompression, and also I had discussed one problem in which the capacity of the evaporator we had calculated. Then today's lecture we will discuss the another problem in which we can calculate the economy of the evaporator and the area of the evaporator. So let us start the lecture. So this is the problem. An evaporator is operating at atmospheric pressure. It is desired to concentrate the feed from 5% solute to 20% solute by weight. So weight fraction is given, or we can say the weight percent, at a rate of 5000 kg per hour. Dry saturated steam at the pressure corresponding to the saturation temperature 399 Kelvin is used. So this is the condition of that steam which is used in that evaporator for heating purpose. The feed is at 298 Kelvin and the boiling point rise or elevation is 5 Kelvin. So this is the feed condition temperature and this is boiling point elevation. So from this we can calculate the boiling point of the solution. So that part I will discuss. Overall heat transfer coefficient is equal to 2350 watt per meter square Kelvin. Calculate the economy of the evaporator and the area of heat transfer required or provided. So for to be discussed what is given in the problem. So data is given as latent heat of condensation of steam at 399 Kelvin, which is equal to 2185 kilojoules per kg. So this data is required for calculation of economy. So latent heat of steam at this given temperature is 2185 kilojoules per kg. Latent heat of vaporization or evaporation of water at atmospheric pressure, this is the atmospheric pressure, and 373 Kelvin, that means at the boiling point of the water it is given as a 2257 kilojoules per kg. Specific heat of the feed, that is CPF, is equal to 4.187 kilojoules per kg Kelvin. So here we are having an evaporator in which 5% you have to convert into 20%. Feed rate is 5000 kg. These are the temperatures of the steam, feed, boiling point elevation is also given, and overall heat transfer coefficient is also given. And this is the additional data is given. So first we have to calculate the water evaporated by doing the material balance. So in previous problem, so this problem I had discussed this how to calculate. So here first we have to write the solute balance. Solute in feed is equal to solute in thick liquor, because we don't have any solute in water evaporated. So that part is eliminated here. So we are having 5, that means in fraction you have to divide it by 100 multiply by feed rate, that is 5000 kg per hour, which is equal to, after concentration we get 20% of solute. So 20 divided by 100 multiply by m dot. So this is the quantity of thick liquor, or you can say the feed rate of the thick liquor, which is obtained from that evaporator. So from this equation, solving this equation, we get the m dot is equal to 1250 kg per hour. Then from solute balance we can write the material balance for the whole evaporator, that is overall. That means we are consider here both quantities, solute and solvent. So kg per hour of feed is equal to kg per hour of water evaporated plus kg per hour of thick liquor. So from this we know that kg per hour of feed is 5000. This quantity we have already calculated here, 1250. So if we subtract this, we get 3750 kg per hour. So this is the water evaporated, or we can say the m dot v. Then we have to calculate the m dot s. So for that purpose, that means kg per hour of steam required. So for that purpose we require this latent heat of condensation, lambda s, then lambda v, or which is equal to lambda, which is equal to 2257 kilojoules per kg. Then you have to calculate the boiling temperature of the thick liquor. So you have to add the boiling point elevation, which is given here. So this is the boiling point elevation, and we know that the boiling point of the water is 373 Kelvin. So you have to take the all units in Kelvin, and elevation means rise. So you have to add this boiling point elevation 5, then we get 378. Then we have already feed temperature 298 Kelvin, and feed rate and specific volume, specific heat is given. Then again you have to write the heat balance, heat lost by condensing steam. That means whenever the heat is given. So this is the input heat, which is equal to output heat. So output is nothing but heat gained to solution by increase the temperature to boiling point, and plus heat required to evaporate the water. So this heat is used for increasing the boiling point of that solution, and remaining heat is used to evaporate the water. So in mathematical expression we can write m dot s lambda s is equal to m dot f Cpf T minus Tf plus m dot v lambda. So we have all these value, lambda s, mf, Cpf, T. We have to just put the value and calculate the m dot s. So solving this equation we get the m dot s. So m dot s is nothing but it is a steam consumption. And what is the formula for evaporator? Economy of the evaporator, kg per hour of water evaporated per kg per hour of steam consumed. So that we have already calculated, 3750 divided by, this is the steam consumption, we get 0.808. So this is the first answer. So this is the steam economy of that evaporator, and we know that this is the single evaporator, so the steam economy is always less than 1. So this value is always less than 1. Then we are having we have to calculate the area. So for that purpose we have to use this formula, Q is equal to UA delta T. So first we will calculate the delta T. So delta T is nothing but TS, that means steam temperature minus T, that is boiling point solution temperature. So we get delta T is 21 Kelvin. U is already given in this equation, and this part, that is Q, you have to calculate from this part. So this is nothing but actually Q. So m dot s lambda s, this quantity is Q. So if you multiply by this 4640 multiplied by 2185, which is nothing but lambda s, we get the Q in kilojoules per hour. But in this problem we have to require this value in watt. So watt is nothing but joules per second. So we have to convert that by multiplying 1000 divided by 3600. So this will convert into joule, and this hours will be converted into second. So we get the value 2816283 joules per second. So joules per second is nothing but watt. So this conversion you should be note or important here while solving the problem in exam. Then you have to put Q, this Q is as it is, U is already provided with U. A, that means area, is asked in that problem, and delta T we have already calculated here. So rearrange this equation, take A this side, other quantities this side, so it will become Q U delta T. So put all this value and get the answer, which is equal to 57.07 meter square. So these are the two answers we obtain. from this data. So in this problem, just you have to first write the material balance, then calculate the overall material balance, then water evaporated, put all these value, calculate m dot s, then from that we can calculate economy, and for area you have to calculate first Q, then delta T, U is given, and from that data you can calculate the heat transfer area. So in this way we can solve this problem. Then here this chapter is completed. So today's lecture I had discussed the how to solve the problem for economy and area of the heat transfer required for the evaporator. Then here the tutorial is provided for you, so that this tutorial will be uploaded in Google Classroom heat transfer. You write the answers of all these questions, and after scanning you can upload this tutorial. So first question is about define the term like evaporation, boiling point elevation, capacity, economy. Then what are the methods increasing the economy of the evaporator? That means multiple effect evaporator, vapor compression system. Then what do you mean by multiple effect evaporation system? That part I had already discussed. Various methods of feeding, multiple forward fed, backward fed, mixed fed. Then we have to write some advantages in application of forced circulation evaporator. Then you have to draw the figure of forward fed arrangement and backward fed arrangement for multiple effect evaporation system. And again you have to draw a long tube evaporator, write its construction, working, and also forced circulation evaporator with external horizontal heating element. That means there are two types, horizontal and vertical. You have to write here horizontal, and you have to also write the construction and working. So in this way we have completed this chapter, and assignment will be tutorial will be posted in Google Classroom. So with this conclusion, I declare that the portion of the heat transfer subject is over. If you are having any doubt, you can ask me on a Google Classroom. Thank you.